Hello friends, I'm Vijay Nakrani and welcoming you to our YouTube channel NDT&Quality. Today we are going to discuss about magnetic particle testing question answers. So I have prepared some question answers for this session, and we will discuss about that question answers. We will solve it. Um Before we start this session, let me make announcement. We are going to start magnetic particle test level 3 preparatory batch from 5th July, um, after 4 days in this week. So whoever interested for magnetic particle testing level 3 batch or basic preparation, or whoever interested in level 3 uh, preparatory batches can contact me. I have given my contact details in description, and let us start this session. So question number one, any material with a negative relative permeability that is slightly less than 1 is. So you have to mark this one option, and the timer is started now. You can pause the video and can solve this question. Um, then you can uh, play a video again. Okay, so uh, here there are four basic type of materials is given in the options: ferromagnetic, non-ferromagnetic, diamagnetic, and paramagnetic. What is the difference of between these options? Ferromagnetic have good permeability, very good permeability. Permeability is very high. Paramagnetic is slightly greater than 1, and diamagnetic have less permeability, negative permeability. uh, and non-magnetic particles, non-magnetic materials do not have permeability. The right answer is diamagnetic, because diamagnetic material have negative relative permeability. Okay, let us check the answer. Okay, so right answer is diamagnetic material. um, let's go to another question. Question 2, the concentration of the solid content in suspension of magnetic particles is measured by. See here, what is written: solid content in the suspension. Then how to measure solid content in the suspension of magnetic particles? Four options are: permitting the solids to settle out of suspension, that what we call is a settling test. uh, B, soaking the liquid in benzol. C, measuring the pull on a magnet. D, weighing the suspension. The mostly student take option A, which is settling test. But here correct answer is weighing the suspension, because it is mentioned as solid content. Look here, it is mentioned as solid content. uh, so option D is right answer. So you just have to see the questions, and you should pause the video. Then you will have to solve the questions. Okay, so question 3, which type of radiation can cause most damage to human tissues? So our options are UVA, UVB, UVC, and white light. So uh, guess your question, guess your options, And okay, uh, so our answer will be UV light, but there are three options in these: UVA, UVB, and UVC. Uh, First of all, what we are using for fluorescent test, we are using UVA light, which is not harmful uh, to human tissues. Um, then, uh, if we are going to shorten this wavelength, then we will get UVB light. UVB light is dangerous than UVA. UVC light is very dangerous, very harmful than UVB. So our answer will be UVC. Actually, UVC light is used for uh, sanitization of materials. We were using this light in COVID times. So here our answer will be UVC light. So fourth question, prod spacing less than 3 inch is usually not practical because. So you should know about the prod technique, how to use prods and what is the spacing. So usually we have two prods or set of prod. uh, so what is what should be distance between two prods. So here it is given that the spacing between two prod should not less than 3 inches. Why? So our options are: option A, the possibility of sparking will increase; option B, more time will be consumed for inspection; option C, particle tend to bend around the prod making interpretation difficult; and option D, it requires more media than 6-inch prod distance. Okay, let us go one by one options. First, we will discuss about D. It requires more media. So, no, it is not any logical option. We will require same media like 3 inch, 4 inch, 5 inch. Then option A, the possibility of sparking will increase. It may be, but this is not the correct answer. Option B, more time will be consumed for inspection. No, it is irrelevant. C, particle tend to bend around the prod, making interpretation difficult. Yes, this is the correct answer, because when we have less prod spacing, the iron powder we sprinkle around the object uh, tries to bend around the prods if prod spacing is too less. Okay, so our answer will be C. Question number 5, which one of the following magnetic particle testing technique is logically acceptable for testing a large flat area? See, uh, the four options are prod inspection, rod shot inspection, coil shot inspection, and head shot inspection. So we should know uh, which inspection technique is useful for which objects. Here, the question is logically, uh, we have a test part which is large in size and flat area. So we can assume it will be a plate, long plate. So what if we want to inspect uh, uh, a big plate? What will be used? Prod, rod, coil shot, or head shot inspection? So if we are using that plate, we cannot use headshot, neither we can wrap coil around that plate, neither we can use a rod shot. We can use either prod or yoke technique. Okay, so yoke is not option here. Prod is the correct answer. Okay, question number 6. A 7-ton coil at 100 ampere is used to inspect a round solid part 15-inch long and 2.5 inch in dia. The length to dia ratio is option A 2.14, option B 6, option C 7,000 ampere ton, and option D 45,000 ampere ton. Okay, so you have to calculate length to dia ratio. Usually we have formula N into I is equal to 45,000 divided by L by D ratio. So here ampere is given, L by length is given, D is given, and N is not given. So but what is question is length to dia ratio. Find the length to dia ratio. So but what students do, blindly put that formula N into I is equal to 45,000 divided by L by D and put the value, but then they realize they are asking length to dia ratio. Length is given here 15 inch and dia is 2.5 inch. If you will divide 15 divided by 2.6, you will get this answer 6.0. Okay, so right answer is 6. This information is given to bluff students. Okay, uh, question number 7. Which of the demagnetization technique listed is most effective? Options are full wave current, half wave current, direct current with reversing and step down control, D variable voltage alternating current with step down control. See here, uh, the catch is we have to do demagnetization with most effectively. So for demagnetization we can use either AC or DC. What is the problem with AC current? AC current gives only skin effect. So if magnetization is in deeper side, we cannot use AC current. We will have to use DC current to completely demagnetization. Okay, so here full wave and half wave currents are alternate currents, and actually all they have single sides, and it gives skin effects. And uh, D variable voltage alternate current. The option C is the correct answer because here direct current is mentioned. Direct current, so we can demagnetize with to up to subsurfaces with reversing and step down controls. So option C is the correct answer. Okay. Now question number 8. When a cylinder is magnetized by a central conductor, the field is most intense. Our options are at the end of the cylinder, at the outer surface of the cylinder, at the inside surface of the cylinder, and option D, halfway through the thickness of the cylinder wall. So the question is, we are using um, central conductor. So let me draw. This is a central conductor, and a cylinder is used. So this is a cylinder. Okay. Okay. We are passing current from this direction. Okay. So magnetization is most intense at which place? The option A is at the end of cylinder, means here. Option B at the outer surface, means here. At the inside surface, ID side. Uh, Halfway through the thickness of cylinder wall, means in mid side. Okay. So correct answer is inside, because uh, the magnetization is, we can see like graph like this. If we are using a DC current, then we will get like this, like this. Okay. So here inside is the maximum um, magnetizations. Okay. Now let us check the answer. Okay, inside the surface of the cylinder. Question number 9. One of the disadvantage of half wave magnetization is that when demagnetizing the current, okay, our options are has skin effect, does not reverse, reverses, passes only on the surface. So let me repeat the question. The disadvantage of half wave magnetization. First of all, half wave magnetization means this is half wave. Okay, so it reverses? No. Has skin effect? Yes, it has skin effect. But this is disadvantage? No, it is not a disadvantage. Um, pass passes only on the surface. Only surface passes? No, it goes deeper too, because it is half wave. But the problem is it does not reverse. See here, it there is only single phase, only positive phase is. Negative phase is crop off or deleted. So if it will not reverse, the polarity will be same. Like if this is magnetized using half wave, then this north pole will remain north and south pole will remain south. If current will be altered, then north pole will be south and south pole will be north. So this is the disadvantage of half wave magnetization. Okay, so going for the last question, question 10. Hysteresis curve illustrate the relationship between. So you should know about the hysteresis loop. This is the hysteresis loop. Okay. The relation is between. So what is the relation? What is on x-axis and what is on the y-axis? Y-axis is B and x-axis is H. What is B and what is H is the correct answer. So our answer will be magnetizing force and flux density B. This is B and magnetizing force is H. So this is our correct answer. Okay, I hope you understand uh, all the questions, and if you want to know more about or have any questions about magnetic particle testing, you can comment in this video, and you can directly contact us. And if you want to enroll for magnetic particle testing, please contact us at the number given in this description. The batch is starting from 5th July, so kindly register whoever want to join this batch, and whoever is preparing for NDT level 3 can also contact us for the preparations. um, Thank you.